All right, we have two different things going on here. So we're going to graph inverse functions. So this one, in a previous video, we found that these are inverses of each other. We had them labeled f of x and g of x. And so we showed by the definition of inverse that these are inverses. But now, just knowing that they are inverses, we're going to show you what that would look like on the graph. So inverse functions, graphically speaking, they reflect over the line y equals x. So if I could lift this off my board and fold over this dotted line, y equals x, the bottom half of this graph is going to land on top of the top half of the graph and vice versa. So let's go ahead and take a look at what that would look like. So in blue, I'm going to graph this first line, 2x minus 4. So that means my y-intercept is -4. So I'm going to start down here. I'm going to put a point here. From there, I'm going to go up to right 1. So up to right 1. You're going to do this, I don't know, as many times as you can. Instead of going up to right 1, though, the other direction I could go if I had room is down to left 1. So the opposite direction, down to left 1. So carefully going to try to draw this line. And so as I connect these points with a line, here's what I get. So here is my f of x. So this is my original function. So this is f of x. Now in purple, I'm going to go ahead and draw f inverse of x. And we're going to see graphically that these are inverses of each other. You're going to have a little squiggly there. But f inverse of x, I have x plus 4 over 2. Now that doesn't really help us when it comes to graphing. So we're going to reduce this. Or write this in slope-intercept form. So what we do is when we have a fraction like this, we can take the left part. So we can say this is actually an x over 2, or 1/2 x. And then we're going to take the right part. Aw, it makes a heart because we love math. So 4 divided by 2 is going to be a positive 2. So really, when I break this fraction apart into two separate fractions, I get a 1x over 2, or a 1 over 2x, or 1/2 x. And then a 4 over 2 reduces down to 2. So these are equivalent, but this is going to be in slope-intercept form and going to make it easier to graph. So from this, then, my y-intercept is this positive 2. So I'm going to go up 2 and put a point. From there, the directions to my other points, I'm going to go up 1, right 2. So up 1, right 2, up 1, right 2. Notice here's where they overlap. Up 1, right 2. Now again, instead of going up 1, right 2, I can go down 1, left 2, the opposite direction. And if I carefully connect these with a line, then this would be f inverse of x. So in purple, I have f inverse of x. So once we can step back with both equations graphed, we can see if I could take this, blue and purple, and fold that over this dotted line, this part of the purple would land on top of the blue, and this part of the blue would land on top of the purple. So these are inverses. We already knew that. That wasn't the goal, is to find the inverse, but the goal is to show you that inverse functions do reflect over the line y equals x. Now, in number 2, right here, we're going to actually find the inverse graphically, and then we're going to put that on the coordinate plane, and we're going to see if we get something similar like we hope. And so one nice thing is, if you graph your original function and its inverse, and they either don't reflect over that line y equals x, then you either did something wrong algebraically when you were solving, or you did something wrong graphically. So I would check your graph first, and then go back and check your algebra if they don't fold. So a good way to check that would be on your graphing calculator, especially for something like the ACT test. All right, so number 2, the second example. First step is we're going to find the inverse of x minus 4. So the way I would suggest is you're going to replace f of x with y. So I'm going to say y equals x minus 4. Do you have to do that? No. But I think it's easier to rewrite y a bunch of times instead of rewriting f of x a bunch of times. Now you're going to flip your x and y. So all I'm going to do is instead of y equals, it's going to be x equals. Instead of x minus 4, it's going to be y minus 4. X and y are just going to flip. From here, you're going to solve for y, or get y by itself. The only thing we have to do that is to add 4 to both sides. Those are not like terms, right? There's your wall if you want a wall. So we get that x plus 4 is equal to y. Now that we found our inverse, so we don't have a bunch of y's here, we're going to replace, since we know this is an inverse, we're going to replace y with the inverse function. So we're going to say f inverse of x is equal to this x plus 4. So I have my original, x minus 4, and its inverse, algebraically we found, is x plus 4. Let's go ahead and graph these. I'm going to use black and label that line 1, and then here I'll stick with black, but I'll label that line 2. So let's see what that would look like. So our original function, x minus 4 that we were given, I'm going to have a y-intercept at negative 4, so I'm going to go down 4, put a point here. From there, I'm going to look at my slope. It is a positive 1. We don't normally write a 1x here, but we know the slope is 1, meaning we go up 1, right 1, up 1, right 1. And we're going to go in that direction forever. We're going to also go down 1, left 1, down 1, left 1, and go in that direction forever. So when I connect these points with a line, should get something that looks like this. And we put arrows on the end because this equation goes on forever. This graph has arrows because it goes on forever in both directions. Now, what about line 2? So this was line 1, our original function, f of x. I guess I can write f of x here. So that's our original. Now I'm going to graph the inverse. So we have x plus 4. So instead of starting down 4, I'm going to start up 4. So 1, 2, 3, 4. And I'm going to, again, same slope, positive 1. So I'm going to go up 1, right 1, and down 1, left 1. What you should be seeing already is that these are symmetrical about that line, y equals x. So this is the second line, or if you want to label this as f inverse of x. And we have arrows going in both directions. So sometimes they cross over this line of symmetry, this y equals x, and sometimes they don't. Sometimes they're parallel lines, but they're still inverses, because if I were to fold over this dotted line, this piece would land on this piece. So here are two methods, or two examples of what you might see when graphing inverse functions.